Hey, this is just a quick refresher on Python so that you can get up and running on it quickly as we're moving through some of these labs using Python scripts and creating them to interact with AI and LLM systems. So first off, why are we focusing on Python? Well, it's a very popular language. We can see here on a survey of people learning to code, it's the most popular language right now for people learning to code. So, and I think a large part of this is just really the whole emphasis around LLMs and AI and ML models with really good library support in the Python ecosystem and a really easy learning curve to get up and running. Okay, I prepared some examples to help us in this endeavor, and these will be posted up to the GitHub, and we'll just kind of walk through these really quickly. Shouldn't take us too long. But essentially, this is what a Hello World app for Python is going to look like. So we're going to go ahead and just print Hello World to the screen. So that's pretty easy. Now, one thing that I like to do is if I'm using VS Code, or Cursor in this case, which is a fork of VS Code, is I like to use this extension, which is called dev containers. So if we go over here to the extensions, we're going to search for and install dev containers. Now, what dev containers is going to do is it's going to allow us to spin up a Docker container and use that for our development environment. So you will need to have Docker installed. Like here, you can see I have Docker Desktop installed. That should be pretty easy to get up and running. You just go download that from their website and install it. I'm doing this all on a, let's see, an M4 chip Mac. So one of the ARM-based Macs. It's just a Mac Mini, right? So that's kind of my demo system for these things. So once you have the extension installed and you have Docker installed, then you'll want to go ahead and create the container. We just do this by doing function F1, and then we'll find this one called dev container, add container, and configuration files. And then we'll just click enter for add configuration or workspace. And then we'll just find Ubuntu, and we'll use Jammy, which is 22.04 LTS, long-term support. We don't need any of this, so we just press enter. We don't need any of this, so we just press enter. Okay, now you'll see that it adds a .dev container folder, and inside there we'll have the dev container.json file. Now this is going to spin up a Jammy-based Ubuntu container. So if we click this button, reopen in container, then we should reload the IDE and we should be inside the container. So now if we click the new terminal button, you should see you're in /workspace/ this is the Python's basics folder. Now any modification we make to this inside of the container will be persistent on the file system. So basically it takes the folder that you had to open inside your Git, inside of your VS Code project, and then it maps that inside the container automatically for you. It's kind of like maps the volume inside and out. The cool part is if we mess up our development environment, we can easily press function F1, and then we can go dev containers, rebuild the container. Now, one thing to be aware of is that if we're using the newer M1 chip Macs or above, then we're going to be using an ARM processor. And so the ARM processor means it's going to use an ARM Ubuntu container. But if we want to, we can easily get a x86/x64 container. And typically the way that I do that is instead of specifying the image here, I will actually specify a Docker file as the image. And then I'll create a Docker file here, and then the Docker file will typically just have one line. It will say from, the Ubuntu image, which is for x86. I'll walk through that in like a future tutorial when we need that, but for these, just for you Python, you shouldn't need that. All right, so look at the code. It just says hello world. So you might get prompted to install this, Python extension. You can go ahead and click install. It takes a minute to install, and then you'll get some better support when you're doing these labs. But I don't know, these are pretty straightforward, so you shouldn't have too many issues. All right, so then we're just gonna go ahead and go Python hello world. The Python command is not installed. All right, so we're gonna need to install Python inside of the container. Typically the way I do this is I just set up .sh file, and this is so if I rebuild the environment, I don't have to retype the commands all the time. And typically the way that I do this is I do a sudo app update, and then I'll do sudo app install Python 3, and then I'll do sudo app install Python 3-pip, because we'll probably install some packages as we go. And then I'll also do sudo app install -i, and then I'll do python-is Python 3. And that's so when we type the Python command, it will automatically map over to Python 3. Typically, that's all we're going to need for this one. So we'll go ahead and click save. And then we'll just type bash setup.sh. I mean, technically we should probably go to the top of this and put this bash comment in just so it's like actually a valid bash script, but either way it's going to work. Okay, so now we go ahead and run that. It'll take a minute to install into this Ubuntu container, but it shouldn't take too long. And then we'll be all set up and we'll be able to test the hello world. Once again, if we rebuild the container, we'll just want to go ahead and do bash setup.sh to install Python again, and then we'll be back in the good state. All right, so that looks like it's all done. Now we'll go ahead and run the first script, and we just see we get back the text hello world. So really easy to print text back to the user to the screen. All right, next let's talk about variables. Variables are, really easy. So here, if you want to do a string, you can put it inside a double quote or single quotes. If you want to do a number, you can just allocate that there. If you want to do a boolean, you can do a true or a false. And those are most of the ones that you're going to use. So kind of these top three right here. Now, if we want to do any type of arithmetic, that's pretty easy. We just add the numbers together, and we make sure that they're not strings. If you want to convert an integer to a string, the easiest way to do that is, integer var, and then string var, something like this. So you would just take the integer variable, let's say, I don't know, like age, right? And you could convert it to a string using the stir parentheses. And then over here, you could have, stir age. Because we're using Python, we should use snake case, which really is these underscores, but I don't know. Sometimes I just do my own thing. So, all right. So, and here we can see if we want to print it to the string, print it to the screen. We typically want to convert it to a string. And there's a couple ways that you can print the variables to the screen. So the first and oldest is basically just using the plus sign on the print statement. And, but we just got to make sure we convert the integers into strings before we do that. So that's, one way to do it. Another way to do this is a little bit newer, but you can use the comma to basically do the concatenation. And when you do this, you'll see you don't need to do the string conversion anymore. And then, last but not least, you can actually use this F string format, and when you're using F string format because it's got an F in front of it. And then you can actually just represent the string straight up in the middle of the text, and you don't need to convert integers into strings for this. Okay, so let's go ahead and run this second hello script, and we can see, all three of these print statements work as expected, and we did not get any errors, so that's great. All right, next, moving on to functions. So as you are building your code, you'll probably want to chunk it out, especially into chunks of code that you reuse. So typically the way that we do that is we define a function. So we use this def, def, then we name the function, then we have the parameters that we're going to pass into the function. Here we just have one parameter called name, and then we're just going to print that out to the screen using the fprint type format. Now, typically you'll see a lot in Python code, basically this name equals underscore main, and then typically it'll jump to like a main function. This is just so like if somebody's importing your code from another Python file, that it'll import correctly, but then if they're running the code native, then it'll kind of follow this code path here. All right, so if running it native, it'll jump over to the main, and then it'll ask for an input. We just use this input with parentheses around it to get an input from the user. That's going to be the name. We'll talk a little bit more about these, but if you want to create a list, you can do that using these brackets right here. You can also convert your list into a set by using this set variable, and then you can also create what's called a tuple just by using these parentheses and around them. Now there are different times that you want to use sets versus lists versus tuples, but in general, if you're just getting started, typically you just use lists, right? Lists most of the time are going to do what you want. One thing that is interesting is, let's say you have a list and you want to dedupe it. The quickest way to dedupe it is actually just to convert it into a set, and then you can actually take that set and just convert it back into a list, and then you'll get a deduped list. So that's kind of like a quick hack to get that done. Okay, so let's run this one and get it going. All right, what's my name? Bryce. It says, hello, Bryce. It has the list, it has the tuple, it has the set. Now, maybe we can show, let's say we insert, a double digit in here. Let's say we do another 3 at the beginning of the list, and now we run it again. We say my name's Bryce. So we can see there's a 3 at the beginning of the list, but then when we convert it to a set, it gets deduped. I believe if we wanted to convert it back to a list again, we would just do, let's see, list numbers equals list unique numbers, and we would just print it out here. So let's give that one a try. Yeah, and we can see it converted it back to a list that's now deduplicated. So, so that's the basics of these more advanced data structures and functions. Shouldn't be too complex, but hopefully that gets you going on that. All right, next I'm going to show you how to iterate or perform a loop. So these are kind of some of the most basic ways to do that. So let's say you have a range, right? Like a number range. And in this example, if you do a range of 5, it's actually going to iterate from 0 to 4. And then when it gets to 5, it's going to stop. So you can say for I in range of 5, print I. So that's going to print 0, 1, 2, 3, 4. All right, next we can do a while loop. Now, a lot of times when I do a while loop, I will actually do something more like the following. Like I'll establish basically like a flag, right? Flag equals false. And then I'll say, while, or I'll say like flag is true. And then I'll say like while true, print looping. If, I equals 3, then flag equals false. And then I'll say like, I plus 1 each round. So that will loop through a few times before the flag flips to false and then it exits out. So that's typically how I use loops. Otherwise, I'm typically using the for statement. I mean, you can do something similar in a while loop as the for statement, but this is just slicker. And then also, you can nest the different types of loops inside each other. So yeah, really pretty basic. Let's go ahead and run this one. Python 004 loops. And looks like I kind of screwed up the logic a little bit on my loop, because maybe the value of I is not consistent in this scenario. So maybe we need to do like I equals 0 before we kick this guy off. All right, now let's open a new terminal. Let's go ahead and run the loops one more time. And maybe we can, just for clarity's sake, we can do like input, press enter to continue. That way you can kind of see the difference. And sometimes, if I'm doing quick and fast debugging, I'll like put the line number here. And I know this will get shifted around, but at least it gives me something to like control find inside of the script and to distinguish between the different lines. So yeah, it doesn't have to be perfect, right? We just got to get it working. So, okay, here we go. So first loop, we can see it did 0 through 4, just as we intended. We got to line 5 in the code, and now we're pressing enter. Next loop, you get pretty much the same thing, but in a while loop format. That's right here. All right, and then the next loop, you can see that it looped a few times before I equaled 3, then it set the flag to false, and then we exited that loop. And then last but not least, we kind of have a double loop going on. So you can keep nesting the code by using spaces or tabs. So, all right, pretty basic there. All right, next one, conditional statements. So we're gonna have a variable, say our name's John. We're gonna say, what is the age? So we're gonna get the age. When that comes in, it'll come in as a string. So we'll use that int to convert it to an integer. And then we'll do an evaluation on the integer. We'll say, if your int age is less than 18, you cannot vote yet. If int age equals 18, you are 18 years old, you can now vote. If int age is greater than 18 and int age is equal to or less than 20, it'll say you are unstoppable. If int age equals 21, it'll say you are 21 years old, you can now vote and hit the clubs. Else, you are an adult or you're just old. That's meant to be a joke. Hopefully nobody takes offense. So these are kind of the evaluations that you can have. You can have a less than, a greater than, a less than, or equal to, a greater than or equal to, an equal to, or not equal to. Those are generally the most common. If you're evaluating multiple conditions, you can use and, ors to kind of concatenate those. You can also use the not to specify the reverse of a condition. So let's just go ahead and try this a little bit. We're going to do Python 005. What's my age? I'll just do the first condition first. I'll say I'm 17. It says you cannot vote yet. All right, so that's cool. All right, now let's run it again. let's say, okay, let's do the next condition, which is, we're age 18. It says you're 18, you can now vote. Okay, now let's try the next one. Let's do something in between 18 and 20. So let's do 19. It says you're unstoppable. And then let's do the next one, which is age 21. All right here. It says you're 21, you can now hit the clubs. And then now let's do an age above 21. We'll do 22. And this should hit the final else statement. So anything that doesn't, define in any of these, it's going to do this last statement here. So pretty basic, but it's necessary to understand this if you're going to write code. A lot of what you're going to do is going to revolve, looping and conditional statements like if or else. So these are key concepts to understand. Okay, one other thing that you should really understand is try catch in Python. This is going to make your code a lot more resilient and honestly just save you a lot of stress and whatnot. So basically, anytime that you do an operation and you feel like, oh, this might fail because maybe the operation is dependent on a user input that you don't control, or maybe you just don't trust your own code because you're like, I'm not that strong at coding yet, right? Well, typically I'll try to wrap as much as possible into a try catch. And typically the way that I will do this is similar to this bottom one right here. So essentially I'll do a try statement, I'll do whatever operations I'm doing, and then I'll just say except exception as E. So this will just catch every single exception type, and then I'll just print out the type and I'll print out the error message again. And that way, I'm covered by any of them. Now, if you know what specific error or exception edge case you may hit, you can actually define those. So for example, if you're doing a division, you might hit like a division statement. Additionally, you can do a specific type of error, and then you can also use an else block to just run code if there is no error. Also, you can use a finally block. This will always run this code regardless of whether the error hits or not. And yeah, last but not least, you can catch multiple exception types using this type of syntax. But really what I use the most is just kind of this statement here, so that I can catch any error that my code might hit. So we'll just look at this real quick when we're running this 006 script. All right, so this try except used to handle errors in code, except division error. That's this first one right here. Can't divide by 0. And then next, we're going to divide 10 by 2. So we should not hit this. But then we're going to execute this else box. You can see that right there. Then next, we're going to divide 10 by 2. It's going to skip over this box, and then it's going to hit the final code and run that. The difference between these two is the else block is only going to run if there's no error. But the finally block is going to run even if an error gets hit. It's going to run the finally block. So that's what the difference between those two are. All right, then next we can see, we're catching multiple errors. And then you can see the type is error occurred, a value error. Oh, that's this last one here. So, when we do some invalid operations, then it's going to throw some errors. And then we can catch the errors there and print them out to screen. All right, so pretty basic stuff. Hopefully the error catching and error handling makes a lot more sense. Talking specifically a little bit more about lists, because we're going to use lists quite a bit. So you can just create a list by using these brackets here. Then if you want to append to a list, you can just do that via the dot append. If you want to insert in a list, you can do dot insert. If you want to remove an item or pop an item off the list, you can do so using remove or pop. And we'll kind of go through and just see what these look like, right? So just say like input equals this. 2, and maybe each time we just print numbers. It's like this. We want to see what the numbers are. Okay, and then great. Okay, cool. All right. So we'll run that, see what we get. All right. Then next, we're gonna go ahead and sort the numbers using the sorted. We can also reverse those and convert the reversed back into a list using the list function. We can count inside of the list. We can also grab the index inside the list. We can do an if statement. If a value is in the list, then trigger on this. Slicing is really important. So it starts at 0 and goes to the second character here in the list. And typically you'll use slicing to, how do you put it? Typically you're going to use slicing to cut up a string, right? So basically a string can convert into a list, and then you can cut it up based on the characters in there. So in this case, you know, you would get like the first character, the second character, and then, you know, after that, it would kind of cut off the list. Let's do a print on that so we can kind of see what that looks like. Great. All right, we can also loop through numbers that are in the list using the for loop. And, you know, there's another way to kind of do something similar here. Okay. 54. Okay, let's go ahead and run this one, and we'll walk through it a little bit more when we're running it. All right, so we hit the first enter. We have this list established with the numbers 1, 2, 3, 4, 5 in the variable called numbers. Then we're going to append a 6 to the variable. So we press enter, and now you can see we have a list that has 1, 2, 3, 4, 5, 6. Okay, next we're going to insert a 0 and a 0 into the list. So let's see how that modifies the list. You can see the insert is saying what place in the list do you want to insert it, and then what value do you want to insert. So we can see it's inserting it at 0, which is the beginning of the list, and it inserted a 0 there. Okay, and the next on it, we're going to remove 3 from the list. So it's going to find any 3s in the list and remove it. So now you can see, you know, previously we had a 3 in here, and now we no longer do. And then if we do pop, it's going to take the last value in the list, so in this case the 6, and it's going to pop that off. Now, I believe you can kind of have you can pop off a value here into another variable. So let's just give that a try and see how that goes. Okay, I'll just Control C this real quick and run it again one more time. Okay, yeah, so you can see when you pop off a value, you can assign it to another variable, and then you can, you know, manipulate those once at a time. This is kind of useful if you're like doing like a while loop or something like that, where you can kind of pop off the values in the list one at a time and process them one at a time inside the loop. All right, next, coming up, we are gonna sort the numbers. So, you know, they probably were already sorted before, so that's not the best example, but that will sort the numbers. And then next, we're gonna go ahead and reverse that sort. So we have 0, 1, 2, 3, 4, 5. So then now we have 5, 4, 2, 1, 0. And, you know, last but not least, we are gonna say if 1 is in the numbers, then go ahead and go down this code path here. And then after that, we're gonna do a slice on it. And we're just getting the first 2 values of it, which in this case are the 0 and the 1. After that, we'll loop through the numbers and print them out, which is what we're seeing here. And then last but not least, we can use the enumerate to go through each of the numbers as well, and keep track of the index as we go as well, using the I variable. Okay, so that's kind of a list in a nutshell. Hopefully that makes a little more sense now that we walk through it. Next, we're going to talk about dictionaries. So dictionaries are a great way to keep track of like kind of key value pairs. So let's say you have a variable called person. Inside of there, you'll have a name, and then the value of name is John, and then you'll have like an age, and then you'll have the age 20, and you know, you could add a lot more here. And then when you want to access, you know, what city does John live in, you can go ahead and do that by these brackets, and then you can pull the name of the key, and then you'll get the value, right? So this isn't pulling it, this is setting the city name here. Yeah. And then we can remove a value from it using the pop, .pop, and then the city, so we'll remove New York from the list then. And then we can iterate through them by doing this for loop where you can get the key and the value for each of the person's items. Next, we can loop through it by using this .keys as well, and loop through it again using .keys. We can loop through it again using the values. So this will loop through all the keys, this will loop through all the values. You can also do like an if city is in person just to see if that attribute is inside of that dictionary, then it's going to trigger this. And then you can also say like if a value like New York is inside of the values, then trigger on this. If you want to see, the length of the dictionary, you can go ahead and just use len. That also works on lists. If you want to clear out the dictionary, you can do .clear. If you want to copy the dictionary to another, frequently if I'm doing like a lot of modifications in my script and maybe I'm unsure that I want those to be permanent, I'll just do .copy to a second copy of the dictionary. Then I'll do all the modifications on the second copy. And then, I can go back and get the original dictionary if I want later on. You can pop the last item from the list using pop item, and you can get specific values here. So here you're saying, hey, get me the city that's in the dictionary. If the dictionary has no city, then just return me the string unknown. So this is just whenever you see .get and it has two variables, you'll see this a lot when you're like reading a config file or something like that. This right here on the right is going to be the default value. Okay, so we'll go ahead and run that one. And then, we'll be able to see, hey, the name is John, the age is 20. We're going to insert a city, and then we're going to pop the city off. Next, we are going to print the key and the value pair. Oh, that's these top ones right here, us printing the key value pairs. I should insert more print statements to make this clearer. And then, next we're going to just name the keys. So we have the name and age key. Then next we're going to name the values. So we see we have John and 20. And then the city's not in there anymore, so it's not going to print this. New York's not in there anymore, so it's not going to print this. The length of it is 2 because it's got the name and the age. And then we got kind of the copy stuff going on down here. All right, cool. Hopefully that makes sense. And hopefully you can, kind of better understand dictionaries. Tuples are another way to access data. They are kind of immutable sequences. So once they're established, generally you're not changing them around as much as you would like a list. They're also typically ordered in a specific order. But otherwise, they're really similar to lists and dictionaries. And honestly, you can kind of get by without using tuples very often. So I'm just going to move forward to the next one. All right, sets. Sets are basically like a list, but all the elements in them need to be unique. Typically, I use sets most of the time just to dedupe my lists. You will see them used in other people's code. Reasons that you might want to use a tuple or set versus a list is it's going to be more efficient in some of the operations. But generally, using lists and dictionaries, you can do most operations you need to for these AI courses. File operations is pretty important. I try to, anytime I do a file operation, I always try to wrap it in a try except. And you don't have to do specific exception errors. You could just do the generic one like we talked about before. One thing that you do get kind of screwed up on when you're reading and writing the file is the encoding standard. So typically I try to explicitly state that, especially, if I'm creating the file. If I'm reading somebody else's file and I don't know what they've encoded it with, that this is a good, place to have try excepts. And then, if it fails, then do another try except for a different encoding type. And typically the error message that you're going to get is going to tell you what encoding type the file is in. Otherwise, open up the file and try to deduce that. So we'll write to a file using the W. We'll read from a file using the R. We'll append to the bottom of the file using the A. Now, if we're doing a binary file, you're going to have to use this read plus. Same with a write plus. And then append plus. So typically you just use those for binary file operations. Okay, I may be mistaken on that, because I guess this write binary is and read binary are the binary ones. Append binary, I'm not really sure what the plus mode does, to be honest. But yeah, typically you just need to know how to read and write to the file, and yeah, that's all you're gonna need for most of this course. All right, classes. Classes are really easy in Python. You just do class and then the name of the class. Here's a person. You can define a function called init. So this is going to occur when you create an object using this class. And then you can have a function that's accessible from this using the greet command. and then you can access the value inside of it using self.name. So we got a person here, we got an employee here. Now an employee inherits itself from the person. This is how you would inherit from another object. You don't need to worry too much about object inheritance, but typically it is nice if you can at least create a basic class to help organize your code better. Okay, and then a little bit more advanced again, polymorphism, which basically, you have classes that inherit from other classes, and they share some attributes and things like that. And you can do encapsulation. Here's an example of that. Extraction example. Composition example. All right. So, but the basic thing you need to know for this class is, this kind of classic one where you're going to establish a person, you're going to name it Alice, you're going to say she's age 25, and then you're going to get the person, and then you'll be able to access any of the functions that are inside that class, like person.greet, this should say like hi to Alice. And you can see that in this class here. So the init is, you need to pass the name and age when you initialize it, and then we just use .self to set it to that object's, set the name and age for that object. And then we also have the greet. We're going to pass it self so it can access any of these values, and then it's going to access the .name value as part of the print statement. Feel free to dive into more of these topics if you're really interested, but for the basics of this course, you just need to know how to create like a very simple class and access the methods and the attributes that are in it. Okay. All right, so one thing that we're probably going to need to do is we're going to need to import libraries, especially as we import the different frameworks for building AI agents. Typically, you just do like an import statement with the name of it here. Another syntax for doing that is like you say from the library import this specific object or function. Like here you can see from random import random int, and then you can go ahead and access any of those code inside of your code. So I'll walk through this as we do those examples, but should be pretty straightforward. All right, this is my quick crash dive into Python for as a refresher. Hopefully, some of this made sense and gelled with you and helped you better understand what you're going to need for some of these courses from a programming standpoint. Now, if you're saying, okay, that was okay, but I need more information, or I just want to get better at this, I do want to point out that at this website, deeplearning.ai, there is a free course which is all about doing Python programming for AI systems. This is 100% free. I've watched this course, and I would, if you felt like you wanted to go deeper than what I just gave you, I would definitely go watch this course. It's really designed for beginners, so it goes over everything in great detail, and especially if you walk through each of the labs, you'll be in a really good position for doing Python programming in the future. So I'd highly encourage you, if you feel like your Python skills still, this refresher wasn't enough, go check out this other course. And that's it for today. I appreciate you tuning in. Please like, subscribe, leave some comments below. I know I kind of didn't give the best explanation about a couple things, so feel free to clarify more in the comments below. And I'll see you in the next one. Thanks.